So I'm back doing my own video for chapter 3, just because I want it done a certain way. So, all right, so we're going to start with a little bit of a review. I'm hoping this is a review, just to kind of remind you what we can do with exponents. And this first one is if we have the same base and they're taken to two different exponents, we can actually add those exponents together. So that's to say that if we have 4 squared times 4 to the 6th, that's going to be 4 to the 8th. And we can do that with, we usually do that with x's. X cubed times x to the 5th is also x to the 8th, and things like that. And the next one, we can do the same thing with division. If I have x to the 8th, x squared, that's x to the 6th power. I don't divide the exponents, I subtract the exponents in order to get this one over here. And I didn't put this on here, but if I have a to the m to the n power, that's when I multiply the exponents. So x squared and then cubed is x to the 6th, whereas x squared times x cubed is x to the 5th. So we know that anything to the 0 power is 1. Anything with a negative exponent pops down in the denominator. This is going to be really important to those of you who are taking calculus next. Because remember, if I have, and then looking at this one, if I have x to the negative 2 power, that's 1 over x squared, and vice versa. If I have 1 over x to the negative 2, then that's x squared. So, and we can do that with anything. If I have 1/2 to the negative 4th power, that's actually just 2 over 1 to the 4th, which is this 2 to the 4th, which we know what that is 32. Well, no, it's not, it's 16. 2 to the 5th is 32. So, there's just a few review things I want you guys to go over. There's a few problems that I want you to do on your homework that just reviews these exponents. So a couple other things I want you guys to review is absolute value. So the absolute value of a number is just the same number, again, if the number's already positive. So the absolute value of 5 is just 5. But the absolute value of if the number is negative, so if a is negative 2, then the absolute value is negative a, which is negative 2, which is positive 2. That's this definition, and that's how that works. So remember, when we do absolute value, we just take its sign off. Everything becomes positive. And then the other thing is fractional exponents. This is another one that's really super important for calculus. So if I have x to the 1/2 power, that is the same as the square root of x. If I have, let's say, y to the 1/5 power, that's the 5th root of y. It is not in a denominator. However, if I have x to the negative 1/2, what would you suppose that is? I want you to think about that for a second. I'll wait. Okay, I hope you thought about it, because that's 1 over the square root of x. Because it's 1 over x to the 1/2, or 1 over the square root of x. And you'll notice this one's kind of interesting too. A to the mn. So if I have x to the 2/3 power, that is the cube root of x squared. That's what that means. And just a reminder that the square root of x, when I use this symbol, it is the positive solution of a equals y squared. That's why a lot of times when we go, if we say y equals x squared, then x is plus or minus the square root of y. That's why we have to have both of these, because this already denotes the positive square root.